All right, so where's your question coming from?
I have two that are a little bit related, that are related to the homework. So the first one would be in 2.6, question 11. It's when there's multiple, like, rational exponents in the equation.
Let's see, where am I at here? 2, 3, 2. Number 11? There we go. Ooh, look at that. So we did at least one problem like this. What do you normally do when you have like 3 terms and it's x squared, x number, yes, when it's like ax squared plus bx plus c, and you try to factor it. So for example, oh no. Okay, we'll do it up here. So, if we've got something like this, how do we attack this problem?
Figure out what multiplies to negative 66 by its up to 5.
Yeah, you want to figure out, it becomes a number puzzle, yes? It becomes what 2 numbers multiply by negative 60. Why? Why does it become that? What do I know? What do I know already should happen? What do I already know? Before you even think about the numbers at all, if you've already thought about the numbers, I don't care. Pretend like you didn't even think about them. What can I already put in there? Why do I only focus on the numbers? Sorry? X and X. Why can I put X and X? Because there's 2 of them here, and then whatever the middle term numbers are, they'll become something X. So does anyone remember what's got to be true about the power in the middle compared to the power in the first place? It's got to be half. Because what do we do with this? We cut it in half. So this better match up with half of this. And then I could just cut them in half. So for example, if I had, so real quick, does anyone know the numbers that work here?
11 and 6.
And who's positive?
11.
Yeah. So we cool with that? And then some of you guys are forgetting to solve it. You got to keep going and get what x is. Okay. So what if instead the problem would have been this? What do you got, Jeff? I don't know, Jeff. How would you start it off? And do you see why it works? If I cut the middle dude in half, will that make the middle terms what they're supposed to be? I need you to see this. If I cut this guy in half, will the middle terms become something x squared? What the shit do I mean by that? I mean this. If I put 11 and 6 here, I get 11x squared minus 6x squared is 5x squared. So if I were to do this, why will this not work? Why can I not factor this easily at all?
Because the x squared is not half of x.
If I cut the first dude in half, like I'm supposed to, and I put them into each little dude, does that match with the middle term? It would become what? It would become x to the, if I cut this in half, what does it become? X to the third. So the middle term would be a couple of x cubes. Is that what it's supposed to be? No, so this sucks. Don't give me that, Jeff. Don't worry, I won't. Not yet. I need you guys to see that. We get so used to seeing x squared plus something x plus some number that we don't even think about why that works. It works because when I cut the thing in half like I'm supposed to, like I need to, it becomes what the middle terms are, and that's why it works. So let's look back at the problem at hand. Number 11? Is that right?
Yes.
Will number 11 work?
Yes.
Is the middle power half the first power? Yes. Good. I heard you. I just wanted more people on board. You guys see that? So then this becomes easy. At least the first step. Can you guys go ahead and try to factor 11 if you haven't done this yet? It's the exact same first step. You take the first two, cut them in half, and then you just have to worry about the numbers. Sure, hold on. Don't say anything out loud. Let everybody try it. Okay. So when I have a problem like this, when it's three terms like this, I break those up so that when I start to FOIL, they'll go back together and make this. But what needs to happen then, the middle terms are going to come in. And if that power, after cutting in half, if that power doesn't match what the middle term's supposed to be, I'm screwed. So this will work because the middle power is half the first dude. And the first thing we do is cut the first dude in half. Do you guys see that? So if the first power was a 10, the middle power better be,
A 5.
if it was x to the 10th, the middle one better be x to the 5th. If the first one was x to the 2/7, the middle one better be x to the 1/7. Are you ready? I'm going to trip you guys up. If the first one was x to the 2w, the middle one better be x to the w. Just cut the damn thing in half, and then the stupid thing's going to work. Isn't that silly? So we're taking something we've focused a lot on, factoring quadratics, solving equations with them in it, and then we go, well, shit, that idea applies to a lot more shit. All I need is the middle power to be half the first dude. And we call that quadratic in form. If the middle power is half the first dude, then it's quadratic in form and it'll work the same way. I can try to factor it. If factoring doesn't work, I can still use quadratic formula, believe it or not. I'll do a problem like that in a minute. So now, I'm sorry, somebody already said the numbers? Careful.
Wait.
Can't be -6 and 1 because that won't multiply to be +6. The funny thing is 6 is so evil because 2 and 3 make 5 and 6 and -1 make 5. Yes? But, or -6 and 1 and -2 and -3. But in this case they have to be the same sign. Yes? Because they have to multiply to be positive. You guys see that? So such a small number, such an asshole. This is such an evil little thing because your brain goes 6 and 1 make 5, yay! But no, they have to be different signs, and these cannot be different signs. So it's got to be yes. What's the next step?
X to the 1/3 equals.
Yeah, this requires this to be 3, yes, to be 0. And on this one, what does x to the 1/3 have to be? 2. And then you got one more step. What a beautiful problem. This is such a math teacher problem.
You plug it in.
Because when you think you're done, you're not done. Because you haven't solved for x yet. Don't plug shit in. How do I solve for x?
Square root of 3.
No. What am I trying to kill? If it was x squared equals 3, I would square root because I want to kill a square. What am I trying to kill?
Oh, do you multiply both sides?
No, this is not cubed. There's a 1/3 power, which is also known as a cube root. And how do I kill a cube root? Cube it. Or how do I kill a 1/3? Multiply by 3. So if you cube both sides, you'll get x by itself. So if I ask you to solve something, and you didn't get to x equals, you're wrong. Something went wrong. You're not done. Most of the time, you just didn't finish, and you're like, I feel like I've done enough work, Jeff. All right, too bad. You're not going to get points, or not enough points. All right. If you did stop here on a test or a quiz, you would get some points. This is why Scantrons don't work for me, because I do partial credit. Yes? So that's why it's always bad to leave a problem completely blank. Now, when I say that, somebody once wrote oranges and bananas. And like, we said don't leave it blank. And I'm like, no, God. If you give a valid mathematical attempt, you'll never lose all the points. You guys with me? If you try something mathematical that has some logic to it, you will never lose all the points. If you leave it blank, you'll lose all the points. Okay, maybe. Always give it a try, because you might think you're wrong and you're right. And then you get all the points. Who knows? Might as well give it a try. Okay. You start to feel, my review days are a little weird because I don't structure them myself. I don't. I leave it wide open to questions you guys have. So you just have to trust me, okay? Any question you have, 12 other people have the same question. So if you're sitting there like, oh man, all these people around me know this shit, not necessarily. You with me? So if you have a question and nobody's asking anything, the floor is yours. And you're like, let me ask that. Yes, so
Could you go over number 6 on the practice test?
6, and then I'll come back to you. Yeah.
This was a quick one in response to this one. So the final answer would be x, little 3 at the top, cube root 3.
No. So I cube both sides. I have to cube both sides so these die, yes?
Oh, okay.
So then what's x?
8.
And do the same thing here. I'll leave you at least one little thing to do in your own. I'm sorry, what was the question again over here?
Number 6 on the practice test.
Practice
for the
test.
calculations.
Oh, this is the one wait, where's 6?
On the back side.
Yeah, this is one of the ones I threw out.
Oh, you threw it.
Yeah, so I'm sorry, if you got the practice test today, we didn't make it to transformations. 3, 5 will be on the next test.
Okay.
What else was it? It was this one. That's related to transformations. That's related to section 3.5. And I think, yeah, we did talk about average rate of change. Okay, I think that's it. Those are the ones I had to throw out. For now. Don't get too excited. They will come back. And the nice thing is, I mean, to be really honest, there's enough stuff. We only have an hour and 20 minutes for a test. So I can't. That's why I made, what did I make? Well, you don't even know this because you haven't gotten part 2 of the homework sheet, but I made 6 tests. Because we only have an hour and 20 minutes each. So I can't like put a lot of stuff on them. Yes?
For number 3, it says use the graph on page 202, but I was having trouble finding that.
Oh.
Number 53.
So I've got the PDF here. Hi, whoa, 202. Was it 202?
Yes.
Go away, you. Okay. That's 183. Yeah, forget the page numbers might be different based on what you're looking at. Let me see what this one does. Okay. Stop it. Alright. I love it. Poor little dude. Technology. No. There we go. Alright. 231. Almost there. What did I say, 202?
Yes.
Here we go. There it is. This one.
What chapter is that on?
So this is section 3. Come on, tell me. 3.1. Yeah, section 3.1. So I think the view online and this are the same, but in the actual textbook it might be different. I think one of them was the page numbers are off. for some reason?
On the PD, like when I download it, it doesn't say the page number on the top corner. It says it just on the side. When I scroll through it.
Oh.
So.
Gotcha. So
Yeah.
it's section 3.1, number 53. That's the one I'm referencing for that. Okay. Obviously in the test, I'll just give you a picture of the graph. I can't let you look through your book. Okay. Any specific questions from that problem? Is everybody with what just happened? Number 3 asked you to look at a graph on page 202. This is actually from section 3.1 homework, number 53. Just in case whatever you're using to look at the book either has weird page numbering system or the page numbers are different. I mean, guys, this is okay. You never have to do the practice test. You guys hear me? Please don't turn it in. I got enough paper. I'm going to give you the answer key, so I definitely don't need you to turn it in. And you never have to do it. It's not an assignment. You don't have to do this. If you're like, dude, I got enough homework, what do you want from me? You don't have to do this shit, so you're fine. But, how many of you guys tried some of the practice tests out? It sounds like a few of you guys. Alright. Right now, if you're sitting there and you got your practice test out, if you look through it and you're like, I don't even know how to do that, ask. This is beautiful. Pretend like I just gave you this test. But, I'm letting you ask questions. That's insane. Yes?
I don't know if you can simplify 2F. I'm sure there is. But
Oh yeah, you can. Does anyone remember how to simplify this guy? Yeah, conjugate. Multiply by the conjugate. What is the conjugate?
3 minus 2i.
That's what's there. What's its conjugate? 3 plus 2i. It's like the difference of squares pair, so the middle terms cancel. I really want this to make sense. Watch. If I multiply by 3 minus 2i, I'll get 9 minus 6i minus 6i plus 4i squared. Yes, did the middle term cancel? And where's the only place imaginary shit still is? Because what's I squared? What's I squared? -1. So this will be, where's the only place imaginary stuff still is? Where's the only place there's imaginary stuff? Where's the only place where there's something imaginary? I love you guys in the middle, yes? In the middle. So don't you want the middle terms to cancel if you want the bottom to end up real? No imaginary part. Just let that make sense. What's the only way I can make the middle terms cancel? If I have the same numbers, different sign. If I had made that a plus 2i, then this is minus 6i, this is plus 6i. And then this is minus 4i squared. So then these cancel then. And then the bottom is real. I love you guys so much. Do you guys see that? So, sure, one level of math is memorize procedure. When I see this, do this. When I see the... The better level is why. Come on. You gotta really mean it. That's the words mean. Okay. These doors can be... No, it's not locked. Trust me.
Oh, it's not?
No. These doors are just mean. Watch it be locked and not feel safe. They're just mean. Okay. Yes.
Oh, after. Can you do 4D?
Is everybody cool with that one? Yes. Okay.
Actually, do have a little question with that.
Sure.
So my answer I got was
God, this
12i
is-
minus 8 over 13. But I was trying to review my work and I saw that it should be like separated. Is that?
Oh, for me, you don't have to. But here's the idea. What does a complex number look like?
It's imaginary.
Like 2 separate terms?
Is the bottom of that f a complex number?
No.
No, not after. I mean, at the beginning.
Oh, the beginning,
yes.
yeah.
Sorry. At the beginning, it's a complex number, yes? It's real plus imaginary. And when I say plus, and you guys see the minus, well, then that's -2. That's the imaginary part, yeah? A plus BI. So when I divide two numbers, shouldn't the answer be a number? When I divide two complex numbers, the answer better be a number. I should be able to write the answer in the form A plus BI. So if you get this, and you should get this, if you circle that, I'm cool. I'm not going to take points off. But could you break that up? Yes. Can you tell what A is now? This is a little bit mean, but what's A? -8/13. So what's B? 12/13. That is A plus BI, just kind of written the other way because of where the negative is. Are you guys, do you guys see it? Yes.
So I know we, to get rid of the denominator, times it by 3 plus 2i. Why don't we talk,
Oh, you have to. Yes. I was
multiply
just being targeted for a second. Whatever you do at the bottom, you have to do the top, which is how we get this. When you distribute that 4i. Yeah. So whatever you do at the bottom of a fraction, you have to do the top. I was just in the moment, just focusing on the bottom. Okay. Hey, don't let me get away with stuff like that. The minute you're like, I thought we had, oh, raise your hand, right? I thought we had to, oh wait. Okay. You guys start to understand, today is wide open. Who gives the first shit if you ask a question and somebody looks at you like, it's your problem? They got the problem, right? Screw them. I don't care what level your question's at. You want to get an answer before tomorrow. So, anything else from the, it could be anything. Homework, practice test. It could just be, we did some stuff with this. Can you do a problem like that? That's a valid question. A valid question is also exactly what's going to be on the test tomorrow. And my valid answer would be, you'll find out tomorrow. Right? I mean, so you can ask any question you want to. I'll just answer some in certain ways. Yeah.
Could you go over to C again? Absolute value.
Do you have a question about this or a different one?
I was gonna
Okay.
say, are there any word problems on the test?
Not yet. I mean, word problems are coming when we get to linear functions. And then, of course, when we get to quadratic equations specifically, there'll be some word problems, yeah. The full-blown quadratic, I should say. Which one again, I'm sorry?
2C in the front.
Oh, yeah. Look at this.
Absolute.
Look at this thing. Here, let me get a clean one. Yes?
Can I get a copy of it?
I guess so. Anybody else got a copy? Yes? Everybody else has got a copy? And if you didn't get your quiz back, see me after class over. So real quick, guys. Somebody already said it. I think you just said absolute values, yes? What controls this problem? See, it's a weird question to ask, but this is always there. But what is this problem all about? Do you have a lot of different operations? Is there a certain order that you have to do them in? Is there an order of operations? Please excuse my dumbass son, right? Have I said this to you guys yet? Or dear Aunt Sally, whatever you like better. Some of you had dumbass sons, and some of you were the dumbass son. I was definitely the dumbass son. Sometimes she says I still am, but we'll get over it. So, in order of operations, where the hell are absolute values? What do absolute values look like? That's a weird question. Something that's in order of operations.
Correct.
They look like somebody took a parenthesis, laid it down, and just did the whole forge thing. They heated it up and hammered it out. Yes. There you go. So they are in the same place as parentheses. So you have to do what's inside of them first, and then you do them. Yes. So here's a really big mistake people make. Can anyone identify the mistake? That's a mistake. So if you think that's not a mistake, it's no good.
Get rid of the absolute.
They forgot
You
to.
solve before solving what's actually absolute.
Yeah, what am I taking the absolute value of? I don't know. But what did they, where, can you see the logic though? Is there a logic there? It's
Yeah.
wrong, but you can see the logic. They know absolute values do what? Make minuses become,
Plus,
so if they just stopped there, they did it correctly in their head, yes? They're like, that's what you said, man. You said absolute values make negatives become plus. I never said that. I said absolute values make negative numbers become positive numbers. I don't even know what the hell the number is yet. Yes? It doesn't make subtraction become addition. I definitely never said that. You guys see what I'm saying? I can't do the absolute value until I know what the number is. What is 3 minus 4?
-1.
Ah! And what's the absolute value of -1?
1.
Get out of here. Yes, very different from 7. You guys with me? Just to save you from yourself. On one level, I need you to understand, I don't blame you. Because you're so hammered in your head, negatives become plus when I do absolute value. But not subtraction to addition. Nobody ever said that. I have to know what the number is first before I can do it. That's why they're at the same level as parentheses, because I have to do what's inside them first. So looking back at the problem. Oh shit. There it is. What would I do first?
7 minus 2/3.
Yeah. 7 minus
8.
8. Can I do some stuff in here?
Yeah.
What do I do first?
12
Parentheses.
over 12 minus.
Right? 4 minus 8. Is that cool? Now, the more comfortable you are with order operations, you can do several things at once. But don't do everything at once. I need to see some work. You will have your calculator with you, and I need to make sure your answer came from your head, not your calculator. So be ready for losing points if you don't show any work. And does everybody understand what's happening now? I mean, there's like 2 problems in one here. 7 minus 8 is...
-1.
Sorry?
I was gonna ask, so if the absolute value is equal to something, you'd have to give 2 answers because it could be or. So like if it's like
Exactly. That's why when we have equations... Yeah.
Yeah, but if the absolute value by itself, you just solve the absolute values. There's
Exactly.
no need to give 2 answers.
Same thing as, what's the square root of 9?
3.
That's insane. What if I said x squared equals 9 and you took a square root? What do we have to put?
Plus or
Plus
minus.
or minus, because we are undoing a square then. If somebody gives me a square root of 9, they've chosen the positive one already.
Okay.
If they give me an absolute value, there's only one thing the inside could be, whatever it actually is. If they give me an absolute value with a variable in it, and it's in an equation, now there's multiple things the inside could be. Here, there's only one thing the inside could be.
Yeah.
Freaking -1.
Okay. But if that was the same problem, but it said equals 4, then you'd write that's the same way you do this, but then you'd also write or.
Yeah, if it was
4.
this,
And there'd be 2 answers.
then the inside could be 4, or the inside could be -4, because the absolute value of 4 is 4, and the absolute value of -4.
Got it. Okay.
Sorry, this should be -4, is 4. Now real quick, down here, 12 divided by -12 is,
-1.
the absolute value of -1 is,
1.
so what's this?
Negative 1.
-1.
Good, because you have that's 1 and you put a negative on it. That's -1, and then what's -1? Okay. Okay. From one of my favorite movies, there's a movie called Stand and Deliver about this dude that took people from pre-algebra through calculus. And there's one scene where he's like, fill in the hole. You have a 1 foot hole, 1 foot of sand, level. So there's a little scene, everybody's like, fill in the hole. Sorry, all right. It's a really good movie. You don't
Is
have to
that the
watch it.
one where they made him retake the test?
Yes.
Because they assumed that they were
I've seen
cheating.
that one, Yeah.
Yeah, and then South Park did a whole parody of it, which is actually kind of funny.
The longest part was like, I gotta get to teach these kids or something.
You have to know how to cheat. Anyway, sorry. And of course, that's the movie 21, where the teacher told them how to count cards. Anyway, that's a whole different. Don't get excited. I'm not going to tell you how to cheat at cards. If I could, I would probably be doing that right now. So what do you say? Actually, I could, but I don't. All right. Is everybody cool with that problem here? So it's an order operations problem, but including absolute values, but they're just the same placement as parentheses. You have to do what's inside them first. Oh. Alright, so we could talk about anything. Yes?
Can we do, 4B? Cause I understood it as putting 0 as X.
Oh, I got you. So I purposefully put this language on here. Number one, to see if anybody would do the practice test. Because I don't think I said it quite like this before. The zero of a function is what makes the function zero.
Okay.
It's a very different, if I wanted you to plug a zero in, I would have just said f of zero.
Right.
Zero of f means I want a zero to come out.
Okay.
So if I had a profit function like, okay, what's the zero of that? I want to know, when do we break even? What's our zero profit? What makes the profit zero? What makes the function zero? So you have to set up an equation. Do you guys see that? 4b is crouching tiger hidden equation. How do you make the function equal to zero? Well, you just take the function. Zero of f means what makes this zero. You take the function and you set it equal to zero. Then a really good question is, how the shit do I do that? Notice something. Is the 2 inside or outside the square root?
Outside.
Good. The most immediate mistake people make is they somehow get it inside, which is neat. What's the first thing I should do here? Is there a radical in that equation?
Yeah, you subtract 2.
Yeah, I try to isolate the radical element, right? We become tyrants of our own country for a moment. There's a radical element in your country. It's disrupting all your plans to control everything and enrich yourself. So what do you do to it? I was about to say something very political. I need to keep that out. I was going to say something about, anyway, stuff you put into tea if it's too warm. And you shouldn't do that because it's bullshit, but we'll be all right. 0 of f. So how do I get this to be the radical isolated? I move the 2. Yes? Okay. Tyrants enjoy that stuff that goes into tea, but we'll be all right. Sorry. It's hard not to be political nowadays. So if you subtract the 2 over, then it can start to free up the x. Is everybody with me? Why is the x not free? It's under a cube root. So eventually I'm going to want to cube. Now here's the thing. I really want you guys to see why we have to isolate the radical first. I need you to see why, if I thought I could just cube, I've got to do it to both sides. And then what does it say? This says write this 3 times in FOIL. No. That's why we isolate the radical. If I subtract the 2, then the cube can just attack that directly. I don't have any foiling to do. You guys see that? Again, there's a process. You can just apply the process and not understand why. Then there's a higher chance you'll forget. But if you understand why the process is there, much less chance you'll forget it. Yes? I don't want to do this first, right? I'm going to make this really clear. No. I want to subtract 2 first. Now what's your question? Is that, was that, okay, good.
I thought you were doing it.
I got to be really careful to immediately cross out the bad shit. I'm trying to point. If I leave that there, somebody's going to go, oh, that's how you do it. No. Now I can cube both sides. And it will immediately do what I want it to do. I want it to kill the stupid cube root, so my x is free. You guys all right?
I'm so sorry, why was D underlined again?
Oh, I don't know. I think I was saying something while I was looking at it. Nothing major about it.
No, somebody asked you to do it.
Did somebody ask me to do it?
Yeah.
Oh,
You said you've been.
I'm such a good guy. So, how do I do this?
You find out what f of 1 would be and f of 15.
I want to see. So real quick, this means from 1 to 15 on the x-axis. And what I'm curious about is, what's the average change in the function over that period? If my, go ahead, sorry. Oh yeah, that would be helpful. Let me zoom out a little bit. So my function is doing weird shit. If my function was the miles I've gone, and the x-axis was hours, yes? You with me? And then I want to know what's the average miles per hour. Okay, that makes sense, right? I want to know how far did I go divided by how long it took. You with me? Is anybody with me? Screw you, Jeff. Does everybody know slope? This is effectively a precursor to slope. This is teaching you that slope exists and lines just happen to have a slope. Too often the way we teach lines is, oh, that's where slopes are. No, slopes are everywhere. Lines just happen to have a really easy slope to see. One thing you learn in calculus is how do I get the slope of a curvy dude? Yes? That's calculus. So slopes exist on their own. They can be used to create a linear function. So how the shit do I do this? Well, if I only knew what the output was at 15 and what the output was at 1, I could see how different they were, yes? So if I do the function evaluated at 15 minus the function evaluated at 1 divided by 15 minus 1, that's how far it went on the x-axis. Does anyone see what formula that really is? How many outputs are in that formula? 2. So this is the second one. This, I'm going to call it, I don't know, I'll call it y2. And this is the first one. I'll call it y1. This is the second input, x2. This is the first input, x1. y2 minus y1 over x2 minus x1. What's that? Stupid slope. That's all that stupid thing is. Another name for slope is the average rate of change. So basically, whatever function I give you, you just evaluate it at the endpoints, take the difference, divided by the difference in the inputs. It's literally y2 minus y1, difference in the outputs, divided by x2 minus x1, difference in the inputs. That's really all it is. So if this was miles I've gone, and this was time, this would be so many miles per hour, or whatever it is. Yes? And that makes sense. We know miles per hour. How do you figure out what f of 15 is? Plug it in. Yeah, do that with f of 1, take a difference, divide it by 14. Woohoo! Maybe? Maybe?
When we plug it in, are we still equaling it to 0?
Hell no.
Okay.
Hell no. Be really careful. Not everything in the universe is 0. That's so nihilistic. If you don't know nihilism, look it up. It's actually a really useful philosophy.
So is that sort of the formula or the end result?
Both. But not really. It's not the end result because I have a lot of work to do. Can you figure out what f of 15 is?
F14 over F14?
No. Real quick. What's the square root of 15 minus the square root of 1? Is it the square root of 14? Hell no. I can't subtract the insides because subtraction is the ass end of PEMDAS. I have to do f of 15, f of 1, and then subtract them. Can you do f of 15? Do we know what f is?
Yeah, it's 15.
No. I know what x is. What's f? This formula, yeah. So just plug a 15 in. Yes? So you can break that problem down into steps. What's f of 15? Plug a 15 in. What's f of 1? Plug a 1 in. Here, go ahead. You guys figure out what f of 15 is. You guys figure out what f of 1 is. You can do it. Yes.
I think I found out f of 15. I got.
Hold on. Don't say anything. I'm sorry.
That's okay.
You guys figure out what f of 15 is. And then we're going to compare your answer to hers. If you want.
Wait,
This doesn't equal 0, right?
No.
You just have plug in.
Nothing in here says anything is 0. Except for part B.
Professor?
Yes.
We got the same answer on the.
Oh, you took one already. Look at you
So-
go.
so- But the thing is, I don't know how you got this, because when I did the f of 1, I got 2 times 1 minus 3, which is going to be negative 1, which is going to be negative 1 plus 2, which is positive.
Yeah. I know. I'll show you. I did something silly, but
Yeah.
and I should have said something. I did something automatically without thinking about it. I'll show you. Don't
We
worry.
got the same answer then.
Yeah, totally. We have to.
You just-
So what'd you guys get for f of 15? What'd you get over there? 5? So yeah, when you plug a 15 in, you get 30 minus 3 is 27. Cube root of 27 is 3 plus 2 is 5. What's f of 1? Yeah, 2 minus 3 negative 1 cube root is negative 1 plus 2 is 1 is
The thing's cut off again.
oh, sorry. Plug a 1 in, you get 2 minus 3 is negative 1. The cube root of negative 1 is negative 1 plus 2 is
3. Wait, negative 1.
let's try this again. 2 minus 3 is
Negative
2
1.
minus 3 is
Negative 1.
negative 1. Cube root of negative 1 is
Negative 1.
negative 1. Negative 1 plus 2 is
1.
1. 15 minus 1 is
14.
14.
4 over 14.
4 over 14 is
2 over 7.
2 over 7. Now, on the answer key, does everybody see that? Doesn't that look like a slope? Rise over run, do you guys see that? Slope is the same thing as average rate of change. It's just that we associate slope with lines, but lines are one thing in this universe that uses slopes. Slopes are everywhere. What I did was something I did without even thinking about it. Do you see how there's a plus 2 here? Do you see when I plug in numbers, there's going to be a plus 2 for both of them? If I subtract, wouldn't that plus 2 cancel? I don't know if you guys see that. I have different numbers here on my answer key. But that's because I killed the plus 2 at the beginning because I knew it was going to cancel. And that's my fault. I did it without even thinking about it. And I'm like, oh shit, you're fine. This is beautiful. If you do this, kick ass. I got the same answer you did. I just did it a slightly different way. Yes.
For B is the answer or one?
For B? B? Part B.
Zero.
Let me see. No. You should get negative 8. You should get negative 5 halves. Right? Because you have to add 3 after you take the cube. Oh shit. Alright. Neat. I don't know. Yeah, if you cube, you get 2x minus 3 equals negative 8, and then you have to add 3, yes? So you should get negative 5, yeah. Did I get negative 5? I did. Go, Jeff.
I got negative 5 with you.
Yeah.
Can we go over 6D or 7D?
7D. 70. How many problems are on this thing? Oh yeah, here we go. Okay, now. I made this easier than some of the problems we looked at. And that's not to make you feel bad if you don't know what to do in Part D, but we did problems with like negative fractional exponents, yes? Let's say that. How many terms are in 7D? 2! Beautiful, there are 2 terms. Yes? Do they have a lot of the same shit? Do they have a lot of the same stuff? Do they both have A's? Do they both have factors that are, yeah, so then it's GCF. That's what you look for. If every term in my thing has common stuff, I think GCF. Let me get that out of the way. So what number comes out? Only look at the numbers.
3.
3 comes out of both numbers. Now what variable is first here? The A's, yes? How many A's come out? 3. How many x minus 1's come out? 2. 9 divided by 3 is, I had 4 A's, we took 3. I had 2 x minus 1's, we took 2. You guys with me? That's literally what you could say to yourself. Maybe not out loud, because then everybody either gets away from you or kind of gets really close to you. And now you just do the same thing with the second term, right? Why does it make sense I'm dividing? Because I'm undistributing. Distribution is multiplication. Undistributing is division.
Where did the bracket come from?
I just want to use a different symbol for some reason. You can use a parenthesis, it's okay. Just make it big. 12 divided by 3? 4. 4. And then 3 A's took 3.
Nothing.
And then I had 3 of these, took 2.
X minus 1.
1 left. I'll use a bracket if there's too many parentheses going to be in there because it differentiates, but you don't have to. And now the only thing I have left to do is distribute the 4. Just to simplify the inside of that kick ass.
If we were to leave it like this on the test, would that be good or no?
That would be bad.
You'd want to
You
continue.
would get most of the points, but not all the points. Even though there's nothing you can do there, this needs to be simplified on the inside. Yeah.
So the plus in between kind of disappears.
It didn't disappear. Does anybody see that plus is still there?
It's
This is huge. I'm really glad you asked that question. This is huge. This first term is there. Plus, right? So now, somebody might say that's not the same as that because I took shit out. So this first term, what's left is there, plus what's left from this term is there. Kick ass. That's why I try to take my GCF and put it a little over, so this could be below and this could be below. Visually, it just makes it so you don't miss things. It's a better way to write it.
So how it's written now would be like how you, if you want to get full points for writing the answer, you have to write it this way.
Yes, but the better way to say that is you have to simplify the inside of that.
Oh, 3
You just have to.
four.
I'm not saying it must be written exactly like this, but the inside has to be simplified. It just has to be.
So do we have to simplify 3a plus 4x minus 4?
Are there any like terms?
No.
No, so you can't. It'd be mean if I said you must. Actually, it wouldn't be. It would be great if I said you must, and you're like, I'm done. I'm done. Simplify x plus y. I'm done. The minute you said it, I was done, Jeff. So here, let me give you the answer key. And as I do this, a word of warning. I think I said this to you last time. Dear God, if you haven't done any of the practice tests, do not even look at this. What you're going to do is this. Yeah. I would have done that. Right? And then you're going to build up false confidence, and that's bad. That's bad. The test is not going to be me doing problems and saying, do you agree? So, don't do that to yourself. Everybody get one? Yeah.
I was gonna ask about
Well, which one?
2A. Don't you flip it because it's a negative?
Wait a minute. Did I forget to flip it? Damn you, Jeff. Oh, I did. I said flip, and then I didn't flip it. Damn it.
Oh, okay.
That's my fault. Yeah, these should be flipped. So this should be,
Can you move it down a little?
this should be this. I said flip, and then I didn't flip it. I love it. By the way, I don't know if you ever had a teacher that was like, oh, I know, Matt, I don't make mistakes. You're gonna, no. I make freaking mistakes, are you kidding me? Just a human. I'm averaging about a 97 on my answer keys. That's pretty good. I do try to be very careful. to get this right, because it does suck when your teacher gets something wrong and you're like, I made a mistake because you got this wrong. So let me know if anything looks incorrect. I feel bad that I let that one slip through, but oh well. Yes?
Can you explain, or how would you explain all integers are rational?
Oh! Yeah, I didn't explain, did I? So, what is a rational number? What's the root word of rational? Root word of rational.
A real number?
No, the root word of rational. Do you guys know what a root word is? The root word? What word is a part of the word rational? Yes, and what's a ratio? What's a ratio? Something to something. That's a fraction, yes? So are all integers fractions? Why?
Put it over one.
You can put them over one. What's a fraction? Any number that could be written in the form whole number divided by whole number, where the bottom is not zero. You guys with me? You guys with me? Any number that could be written as a ratio of integers, where the bottom is not zero, is a fraction. So 7 is a fraction because you can put 7 over 1. Or if you want to be more creative, 14 over 2. Ooh, nobody would argue 14 over 2 is a fraction. We all know 14 over 2 is a fraction. It can be reduced to 7, so 7 must still be a fraction. 7 over 1. We just don't write the 1. We know it's there. You guys with me? Does part B make sense, 1B? Where do complex numbers come from if the square root has a negative on the inside? And there's always a plus or minus, so there has to be two answers then. So complex numbers always show up in pairs, if they show up at all. That's huge. It's going to become very huge pretty soon, what I just said, yes.
Will it ever be plus or minus 0, meaning?
Totally. We talked about there could be one answer. In that case, it's kind of like a repeated answer, but then that means it would be real. Because the only way it could be complex is if the radical had a negative inside, and you just said it had to be 0 inside. So,
Okay.
yeah. Yes?
For 5D, you said that there was no solution, but I thought if you put it to the power of 2.
5D. Yeah, no solution. Yeah. There's no way in hell. Again, when I say square root of 9, what's the answer?
3.
Why is it not negative 3? Because square root of 9 is the positive answer. So this says the square root of x plus 1, it's positive, equals a negative number. Can you have a positive number equal a negative number?
No.
Nope, no solution. If you square both sides, will you get two answers? Yes, if you square both sides, you will get two answers and both of them don't work.
I'm saying, if you want to leave x by itself, wouldn't you put it to the power of 2?
Yes, you ready? I'll do it. Here. Let me write the problem down. What do I do from here? If I don't notice this, what do I do from here? Square both sides. I get x plus 1 equals 9. Yes. And then I subtract 1, x equals 8. Yes?
Okay.
If I plug that in, let's check it. Square root of 8 plus 1 plus 5 equals 2. Don't check it here. Check it here. You always have to check your answer in the original problem. Square root of 8 plus 1, square root of 9 is 3 plus 5 is 3 plus 5 equal to 2. No, so that's why there's no solution. The only possible solution didn't work. Did you have to get there? No, you could stop the minute it says square root equals negative. Or if I had one absolute value equals negative. I can stop. I can stop and say no solution. Leave me alone, Jeff. I'm not going to fall into your trap. I'm on to you, math boy.
So on the test, if we see a square root equals a negative and we just put no solution without showing any work, we use that's good.
It'd be a good idea.
If you,
I mean, if you did exactly this, I'd be happy. I'd be happy. Yes. Don't say right here no solution, because then you're not showing me how you could tell. You got to go that next step.
How
Because, how do I say this? Okay. How do I solve this? And when I do that, what do I put? So do you agree there is a positive and a negative answer? Yes? So this is the positive answer, this is the negative answer, correct? So when I see a square root, somebody has chosen the positive answer. And that equation says a positive number equals a negative number. Is that possible? No, so no solution. I don't have to go any further. It's trying to say a positive number equals a negative number. I'm like, you silly equation. It's not its fault. It didn't want to exist. Existence is pain. Okay. You guys kind of with me?
So that's like always the case when it's like equals negative.
Yeah, absolute value equals a negative means no solution because absolute value in here, in just definitionally has to be at least 0. Can't be negative. Square root definitionally is positive. If I wanted the negative root, I should have had a negative sign in front of it. Yeah. Yes.
For 4a, finding the domain under f function, do you put just the stuff under the radical, or the whole function has to be greater than or equal to 0?
Oh, I love it. Okay, you ready? You guys really ready? All right. If I don't say we can use imaginary numbers when we give you functions, we're assuming it can't be imaginary. Are you with me? So, with that understood, what is the square root of negative 4?
2i. Oh wait, sorry, for no solution?
No solution. No real number, right? So no solution. You with me? This problem gave me functions. It didn't say I could have complex numbers. So if there's a complex number, I can throw it out. You with me? You with me? What's the cube root of negative 8?
-2.
So can we do the cube root of negative 8 and it stays real?
Yes.
Yes. You with me so far? You with me so far? So a square root, if that function was a square root, there's certain inputs it cannot handle, correct? What kind of inputs can a square root not handle and stay real? Negatives, yes? You guys with me? Cube roots, can they handle negative inputs? Will they stay real with negative inputs? Yes, the cube root, you just told me the cube root of negative 8 is negative 2. That's a real number. We wish it wasn't, because then debt wouldn't be a thing, but too bad for us. You guys gonna? So with all that shit said, the cube root does not care if the inside is positive or negative. So is there any x I can't use? Is there any x I can't use? Knowing that it doesn't matter if the inside's negative. Is there any x I can't use? Is there any number I can't double?
No.
Any number I can't subtract 3 from? Any number I can't cube root? No. So for f, the domain is all real numbers. Or negative infinity to infinity, if you want to write it like that. You guys would. So listen, here's the really cool thing. And why is that true? Real quick, what do you get when you square negative 3? Take negative 3 and square it. 9. What do you get when you cube negative 3?
Negative 27.
So cubes preserve the sign, squares don't. In fact, every even power kills a sign, every odd power keeps it. So every even root can't handle negative inputs, and every odd root can. So if I would have put a 33rd root, the domain would be all real numbers. 34th root, I'd have to do some work. Now, your real question was this, because you know I'm going to do this. What if this would have been a square root here? So what if the problem would have been this? So it's a really good question. When I ask you for the domain, the real question was, do I have to take into account all of the function, right? Can somebody tell me what cannot happen in this function? Since I don't say we can use complex outputs, what cannot happen in this function? Be very,
Can't equal negative.
what specifically can't be negative.
Step under the radical.
Stuff under the radical can't be less than 0, yeah? Can't be negative. You with me? What's under the radical? Let me write this down. Stuff in radical can't be negative. I'm not sure I can call this English. This is at least Jeffish. So this is Jeffish. How do I translate that into Mathish? What's inside the radical? 2x minus 3 can't be negative, so it must be at least
Positive.
0. So did I care about the plus 2? No, because the plus 2 is cool. Just adding 2, that's not going to make any, oh my god, I'm adding 2, holy shit, I gotta be, no, I don't have to be careful. The radical, oh shit, the radical piece, I gotta be careful. I can't let the inside of it be negative. But it's a really good question somebody has to ask. I know what you meant. Do I have to worry about that plus 2? No, because it's not inside the radical.
So it was a cube that was popping out.
Since it was a cube, the answer is all real numbers. If it would have been a square root, then it would solve this, and that would be the domain. Yeah.
So when it comes to cubes, we don't have any dividing variables?
Cube roots, fifth roots, so forth, they can handle negative inputs.
So you can imagine.
There's no imaginary numbers. Well, let me be careful. I'm just thinking a cube root, it's an odd root of a number. There won't be any imaginary numbers.
Okay.
Yeah.
Thank you.
You won't. Do you guys really get why? When I square something, I lose the sign. When I cube it or fifth power, whatever, I don't lose the sign. That's why cube roots are cool with going backwards. What did I square to get 9? Do you know exactly what I just squared in my head to get 9? What could it have been? 3 or?
Negative 3.
Oh shit! Well, what did I cube to get negative 8?
Negative 2.
Negative 2, that's it. That's the only thing I could have cubed, yes? That's why odd roots are cool with negatives. Even roots freak out with negatives. Okay. So, don't forget, you're surrounded by people that want to help you. The Math Science Center, the CISL, my office hours, all that stuff. If you're really behind on the homework, stop doing every single homework problem. Make sure you get some done out of every section. That is your immediate concern for yourself. Okay. All right. I'll see you tomorrow.
This is for homework turn, right?
Yes, thank you. Quiz? Name again?
Oh, Marion Gold.
Ah. Someday I'll get that in my head.
Thank you so much.
Huh? Quiz. Right? No. Rami. And you are. I forget your last name. Oh, here you are. Is this you?
No, I'm eating my lunch.
Yes. Okay. Of course.
Go ahead.
Of
Oh,
course.
sorry.
Right there.
Is it okay if I put like one section on the front, one section on the back? Or should I
Of course. No, you're fine.
Thanks.
Yeah. Kill less trees. Tomorrow's fine. They're due the day of the test. Yeah. So 3.4, 3.4. Yeah. See you.